Hey everybody! Today we are going to be doing the notes for solving equations with distribution. So if you have the notes page, go ahead and grab that and get it out. If not, just follow along, no big deal. If we have an equation that has distribution, there are three main steps. And when we were modeling an equation briefly, we did that in a previous video, we already covered two of these steps: eliminate the constant and isolate the variable. All this does is add one extra step, which is what a lot of 8th grade equations do. They add one extra thing that you've got to do. So in this, the extra step is we need to distribute. And we already know how to distribute. It's when we have these parentheses, and it means that we are going to multiply, but we learned how to do that when we simplified expressions. So I'm going to draw my little lines there. I'm going to come over to Desmos. I'm going to use Desmos so I don't make any mistakes. I'm going to do 2 times 5 and 2 times positive 1. So on the left side of my equation, I get 10x, don't forget the x, plus 2, because that was a positive 2, equals 5. And I almost forgot the very, very first step, which was draw that line dividing the left and right side of my equation. Oops. So I can check off distribute. My next step says eliminate the constant. So on the left side of the equation, where my variable is, that's the side I always want to be focusing on, whichever side has the variable on it. In fact, let me put a little star on this left side. On the left side, the constant is 2, and it's a positive 2. So if I want to eliminate that 2, I can't just erase it. I can't just cross it off like I did with the model. I have to use an inverse operation. So since it's plus 2 right now, I'm going to subtract 2. And let me show you in Desmos why I'm doing that. If I have a positive 2, you can even put the plus there. If I have a positive 2 and I subtract 2, what happens to it? It becomes 0, right? They essentially cancel each other out, but they become 0. So if I do that, on the left side of my equation, those are gone, and all I'm left with now is the 10x. So I'm one step closer to having my variable completely isolated. But you have to keep things balanced in an equation. So if we subtracted 2 from the left side, we need to subtract 2 from the right side. And then we pop over here to Desmos, we do 5 minus 2, and that gives us 3 on the right side. Now we're almost done. We only have one step left, and that is to isolate the variable. So my variable is x, and right now that x has a 10 that is leeching off of it. They are attached whether they want to be or not. So I got to figure out how to get rid of that 10. If this is 10 times x, the inverse operation is division. So I'm going to divide by 10. And since I know I have to keep my equations balanced, I'm going to divide by 10 on both sides of my equation. Now again, let me show you why I do that. So on the left, I have 10 divided by 10, and that gives me 1. But I don't need to write 1x down here. I can just put the x, because that means that there is only one of them. So I have isolated my variable. I just got to figure out exactly what it equals. And you can write the answer to this two different ways. You can do 3 divided by 10 and get 0.3. Or you can leave it as a fraction if that is what you or your teacher prefer, and you can just leave it as 3/10. Now, there are two ways to check the answer to this. If you have the notes sheet in front of you, this is what it says for checking the solution. It says to take whatever value you got for x, substitute it in place of the variable, and then you would use order of operations to see if you get the same number on the left side as you do on the right side. I'm going to tell you that if you have Desmos, there is an easier way to do that that doesn't require so much work. So let's look back at the original equation. I'm going to highlight it here in yellow. Okay. I'm going to take the side that I put that star by, the left side, the side with the variable, and I'm going to type that into Desmos exactly the way that I see it. 2 parentheses 5x plus 1 parentheses. And I'm not going to put the equals 5. I'm going to let Desmos tell me what that equals after I tell it what I got as my answer down here at the bottom. So I got x equals 0.3. And then look at that first line. It says equals 5. And if you look back at the equation said it was supposed to equal 5. So that's how I can use Desmos to check my answer and make sure that I have solved it correctly. I love the old school method of plugging in our number for the x, substituting that in and using order of operations, but there is nothing wrong with using your tools, so I'm going to use Desmos to check my equations. Boom. And that one's done. And I think the next one's going to go a little bit quicker because now we already pretty much know what we're doing. This time I won't even forget to put the line. I'm going to go ahead and distribute to both sides. -3 times x is -3x. I'm going to go ahead and make sure I do -3 times 5 in Desmos, and I get -15. Bring down this right side. And then from there, I'm just doing basically a 7th grade equation. I'm going to eliminate the constant, which is this -15, by adding 15 to both sides. That'll give me -3x equals 6. Although I should have used Desmos, so let me type that in real quick. Gives me 6. I've eliminated the constant. Now I'm going to isolate the variable. So the number that's being multiplied by the variable right now is -3. So I'm going to divide both sides by -3. And that's going to give me x equals, wait, let me be a good student, -2. And I have isolated my variable. Now, let's do what is possibly the most important step, and let's check our solution. You can do this by plugging in the value that you got and using order of operations. That is a beautiful way to check your equation. I'm going to use the Desmos method because it's quick and I like to use my tools. So I'm going to go back to the original equation, take the side that has the variable, put that into Desmos, and then I'm going to put in my answer, x equals -2. And if you look in Desmos, that gave me -9. If you look back over here at the original equation, I was supposed to get -9. So that means that I did, in fact, solve this equation correctly, which is awesome because this is an 8th grade level equation. We are not doing baby stuff anymore, people. This is 8th grade stuff. Good job.